Greetings. Let's have a quick introduction, motivation introduction to the Klein for group. So it can be denoted as K sub 4 or V, and it has 4 elements, and it's the smallest group that's not cyclic that has 4 elements. It's the smallest group that's not cyclic, and it has 4 elements. So that says the smallest group that's not cyclic has 4 elements, and it is a very interesting group, a very special one. Of course, it has up to isomorphism many variants in how we can show the elements. So many groups are the Klein for group, but they have different elements, but they're isomorphic to each other, so their structure is fundamentally the same. And so we have many ways that we can choose to represent it. And one very nice way, elegant way, is we can take any 2 elements, satisfy that a squared, or the second power of the element, right? So the element in operation with itself is the identity, some other elements also, and also if we put the element in operation with each other, and then that to the second power is also the identity, all is equal to each other. So this is an interesting way to denote the group. What it says is that every non-identity element has an order of 2. So take the second power of any non-identity element to get the identity. Of course, the identity element, its order is trivially itself, it's already identity, so the order is how many times we have to put it in operation with itself for it to become identity. So with the identity, it's 1, of course. But with the non-identity element, it's 2 in all cases in the Klein for group. And another interesting thing that we can mention here is one very interesting representation is by Z2 in a direct product with another Z2, which are groups of elements 0 and 1, with this where we create these ordered pairs out of them. So we can say that, V is a very common way of representing, but let's now say P4. It doesn't really matter, but we can talk about the group also in a concrete sense. So let's choose a way to write out the elements. So up to isomorphism, as I said, there's many variants, but this one is very common to take into account. So 0, 0, 0, 1, 1, 0, 1, 1. So these 4 elements are what the group consists of. And we can check that what was noted here and what was also noted, what I noted in the meantime when talking about it, is fulfilled by these, all right? So these 4 elements are a way to denote the Klein for group. Okay, so this is an instant of the Klein for group. So any 2, also another, a very important thing to see, any 2 non-identity elements will produce the third non-identity element in operation together. So, put 2 non-identity elements in operation together, it produces the third non-identity element. So that works. We can check it with concrete examples, for example. So that will be like this. For example, this gives so we see this is the identity. We can say this is 1 non-identity element, another one, and the third one. So B, A with C gave B, and the same as B and C will give A and B will give C, and so on. And the addition is of course component-wise. So the operation in this instance of formulating a concrete case of the Klein for group was more to addition component-wise, add the components and then divide by 2, and the remainder is the result. All right, so this is sort of it. We could also illustrate in this concrete example that every order of every non-identity element is 2. But you can see 1 and 1 is 0, 1 and the more 2, 1 and 1, 0. So add this to itself and it gives this. This is the identity here. All right. So this has been some introductory information with the Klein for group. And of course there's far more to it. But to revise, once again, it's very, very, very important group. Has 4 elements and it's not cyclic. And a very common way to represent it is, for example, this way.